Good evening. Thanks for coming. I will step forward. Anyway, so I'm going to talk a bit about Gatsby. I'll do a little bit of a comparison as well to both Create React App and Meteor, and just talk in general about what sort of Gatsby is and what it means to have a static site generator, that sort of thing. Yeah. Okay, so what is Gatsby? Before we get into that, I'll put it in a little bit of context. Gatsby is built on top of React, right? So you have to understand a bit about React and what React does to know what Gatsby does, in some senses. And so React is somehow about taking data and turning it into a DOM, right? So it's, somehow you take data of different kinds and you take something like a template and you combine them together and the output is a DOM, right? Which is rendered on the screen. And so a component in React is something like a template, but it's also not a template, right? Like it doesn't use templates, it uses a component. And so there are some differences between these. So I'll give you an example, the blindingly bright screen. So this is a view template, right? And it looks a lot like HTML. So there's a UL tag, and then the li tag has a v-for directive, which tells it that it should loop over name and list of names. We have to put the name inside and then we close it. So if you speak HTML, this is fairly straightforward, right? The same thing shown as a React template is something like this. So here we're defining a function, which is called list, and it takes a parameter. Here I'm showing off a bit and using flow syntax just to show the shape of the variables. So the parameter that's passed to the function list, usually called props, should be an object, and it should have a property called names, and names should be an array of strings. So that's what the first line tells you. And then we're using some ES6 magic, so there's an implicit return here because we have a comma, an opening bracket in the first line, so the rest of the whole thing gets returned. And then it looks somewhat similar in that we have an opening and closing UL tag, but in the middle line we're using JavaScript to map over an array. And what this does, there's a lot of like ES6 magic in here to make it compact and look like a template. What it does in that middle line is it calls this function map, and then what's given to map is another function which takes the name as an input and returns an li tag with the name in between the opening and closing tags. And this is possible because of JSX, which is an extension to JavaScript syntax that allows you to write things like a UL tag inside of a JavaScript file, and this gets compiled or transpiled into a react.create element ul blah 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 or whatever. So the syntax looks somewhat similar, but there's quite a lot of difference here. Like if we go back to the template, this is just like HTML, right? And we have this for, which is some kind of magic syntax, which I guess you have to know from Vue. I don't know what Vue actually, so I just copied and pasted this from somewhere. And that, this is pretty similar to HTML, handlebars, blades from the Meteor world or whatever. There's quite a limited scope to what you can do here. Like you can output data and you can use directives that exist like v-for and so on. And that's more or less it. Like certainly in the blades world from templates, that's about all you can do. You can output stuff. Whereas here, in the component, this is JavaScript. So you can do anything you want here. So one example is if you wanted to have your rows with an alternating style, in templates, like in Blaze, I would create a helper which would have to figure out, which would have to keep some kind of counter, like it would be kind of complicated. I'd have to add context to my values and so on, so that my for loop would know which row it was on. Whereas here, because this is a core.map function, the second parameter will be the index. And then I could have inside the li, for example, I would add a second parameter after name that would be index, and then inside the li, I could add a class name and I could just do if, like I could have a ternary operator that says, if I modulo 2 equals 0, then add the class blah, and otherwise have a different class. Now, what we were saying earlier about developers versus designers, if you're a designer and you're used to HTML, then the first thing is probably easier because the developer probably has to solve that problem for you. It's kind of outside of your problem domain. And so someone else is responsible for dealing with that. Whereas here in the template, it's easier for me as a developer because I can use all the JavaScript magic that I'm used to, but it's more difficult probably for a designer because you have to speak a bit more JavaScript. So there are pros and cons. But and it's not super even important for the presentation, but it's just as a sort of snapshot of what React does. Like fundamentally it takes data and it generates stuff. And it does that using something that's much more like JavaScript than a traditional template. The other thing that I'll touch on later, but I can mention now, is that you typically, the idiomatic approach to React is to put your styles in your components. So in this file, there would be styling information. And ideally, you would put it into some kind of shared file so that you have variable names that define your styles. So you have colors defined as variables and you import them and so on. And again, as a designer, maybe more tricky. As a developer, super easy because you just use variables and you import variables and you get them from other places and you use them in your styles and you modify them and you build on them, etc., etc. So you're building not only the shape of the DOM, but also the styling that is attached to that in JavaScript inside of your components. Yeah.
Yes, just a short about this indexing. In Blaze, you have this @index that you can do in a Blaze template loop. Each blah blah.
That's true.
@index mod.
So in Blaze, that's true.
Odd.
In Blaze, you have the index, but you would need a helper to be able to figure it out. Like you need to be able to do something with it. Like it's not, you don't have a simple way inside the template. You can't write functions, you can't write code inside the template. You can't do comparisons or stuff like that.
I always have a kind of a set of standard.
Yeah.
My helper is equal,
Right.
is better, is
Yeah.
green.
Right, and then so you end up building stuff like that, which has to be done by a developer. So it's just a separation. Like there are pros and cons to each. For me as a developer building user interfaces, I much prefer with a component model now that I've used both. In the beginning, I was very resistant to it, but now I much prefer it because it's way more powerful, and because I understand JavaScript. For me, it's very simple. But I recognize that as a designer, it's maybe a more difficult paradigm. Okay, so that's a quick short summary of React. So if you want to get React running, how do you do that? And one of the simplest ways is create React app, right? So the state of modern JavaScript is that you need Babel, right? And Babel allows you to, one, do this magic JSX stuff that I showed you earlier, but Babel also allows you to write stuff like this and have this compiled into something that the sort of average browser in the wild can use. And so there's a few things happening here. Like first is the const keyword, which is not part of the ES5 or whatever syntax. Then there's the fat arrow function, which again is not, which is another magic thing. And it's also, no, it doesn't have an implicit return, it has an empty return, I guess. Anyway, if you want to use this kind of magic new JavaScript stuff, then you need to transpile that into something that older browsers can speak. And that's where Babel comes in. And then you also probably need Webpack to get modules together and build the whole thing and combine it all out into one file and all sorts of other magic. I actually don't really know what Webpack does. I've never really touched it directly. The only thing I know is it's a little bit like Postfix back in the day, like a lot of configuration options and best avoided if possible. That's my impression. So you use create React app, you get an application, you get a nice easy command, yarn build, and that takes your code, bundles it all together, builds it out, and spits out files at the end of it, right? And it makes your life very, very easy. Like you can just create stuff and it will automatically be dealt with and it stays out of your way. It even includes a service worker. So your files get cached in the browser, loaded fast. Like there's all kinds of really complicated, very sophisticated magic happening inside Create React app that you just don't have to care about. And that's sort of the state of modern JavaScript. Like you can't, they're gone are the days where you just can write jQuery, include jQuery and start writing code, and it will just work everywhere. Like nowadays there's so much complexity and evolution and different libraries and so on that you need this whole build pipeline to be able to deliver JavaScript in a way that browsers can understand it, right? And so that's what Create React App does. It abstracts all that stuff away, and it makes React super easy to get started with. You just run the command Create React App, give it a name, and you get a directory, and that's it. There's no backend, so it outputs just HTML and so on. There's no server. You don't have any, like you have a server running locally when you're in development, so you get hot code reloads and so on. But once you run yarn build, there is no server. It's just static files, right? So it outputs HTML so that you can load the JavaScript and so on. It outputs JavaScript, and it will also, Webpack will build CSS and allow you to do all kinds of magic with that. So that's Create React App, which is maybe the simplest way to get a React application running, right? So the next sort of step in the evolution is Meteor. And so what is Meteor? And I'll skim through this fairly quickly because I assume that the audience are somewhat familiar with Meteor. So Meteor, first of all, is a full stack JavaScript framework. So it is both client and server. That's an important part, right? So it has a server, and that server is built on Node, and it has all kinds of stuff happening on the server. The server is stateful, which can be quite significant. You have like, there can be, it's very nice in the beginning because it makes certain things very easy, but over time it becomes increasingly painful because certain things get more and more tricky to do. So, especially with Meteor, because it has this magic of fibers and futures, so it allows you to write synchronous code on the server, so you can do things like something.find.fetch, and you get a result back on the server. The difficult part about that is that Meteor has lots of magic under the hood about knowing which user a given function is currently being executed for. And that state and context has a whole pipeline as to how it gets managed and how it gets delivered and et cetera. And you need, at some point, you will run into this where you will just try to, often you try to do something asynchronously on the server, you get a callback, and the callback has lost that context of which user was logged in and et cetera. And so, yeah, the statefulness of this, you probably will run into problems at some point. But at the beginning, it's very nice. And that's really what Meteor is all about. It's all about developer experience. If you want to get started building an application, even today, there is nothing as fast and as easy as Meteor. You can just run Meteor, create foo, you have an application, cd foo, Meteor, and it just runs. And everything's done for you. You didn't have to install Node, you don't have to install NPM, you don't have to install anything. It's just done. You don't even have to install Mongo. Like Meteor just makes your life very, very easy to get started building full stack JavaScript API applications. And a big part of that is isomorphism, which for many years I did not understand what it meant. It's a fancy word that means being able to do the same thing or write the same kind of code in different places. So Meteor has its own remote procedure call type of system called Meteor methods. And so you define a Meteor method like meteor.method, and then you give it a name, etc. And then you can run meteor.call, for example, where you give a method name as a string, and you pass some arguments, and you get a result. And you can do this client or server, and you don't have to care. So in many ways, this makes life easy. You can write things, and you don't have to worry about where you are, or you have to worry less about whether you're running on the client or the server. One of its greatest assets, also one of its greatest weaknesses in the sense that when things start to grow in complexity, this becomes really complicated, trying to understand which context am I running in, is it client, is it server, etc. Likewise, you can also do this with collections. So this is an example of a Mongo collection. You can do collection.find1, and this will run synchronously on the server. When Meteor launched like 4 years ago or something, 5 years ago maybe, this was super mind-boggling. Like no more asynchronous JavaScript on the server. This was really awesome. Like callback hell, gone. I want a document, I do collection.find1, I get the document back, my life is easy. Meteor under the hood is using fibers and futures to make the node process stop and wait here, wait for this to execute. Once it's returned, then it continues execution. Super, super nice. Unfortunately, the JavaScript landscape today has moved in a different direction, and now it's more gone in the direction of promises and async await, which Meteor somehow supports, but this pattern, while it was revolutionary and awesome in the day, just has not gone mainstream. And again, there are just weirdnesses to it that you need to understand, and which you understand only by using the Meteor ecosystem. Like, these are not patterns that you apply anywhere else. Whereas if you're using promises and async await, then that's a broad JavaScript pattern that will help you out in other places. Another thing that makes Meteor really awesome from a developer experience point of view is Meteor Deploy. So you can run Meteor Deploy, and if you pay the company that makes Meteor MDG for hosting, this will just upload, and it'll build, it'll upload, it'll trigger a new deploy. The whole thing is done for you. You really don't have to do anything. You just run one command, game over, it's live. You can also run build, Meteor build, and it will spit out a bundle, which you need to run on Node, so there is a server, which is unlike Create React app. You're tied into Mongo with Meteor, so it's the only data source that's really supported out of the box. Yeah, you can do other things, but it gets tricky and you have a lot of async problems, etc. And so Meteor is really good when you want to do things that are dynamic. If you want to have data and different views for different types of things, then Meteor is a good fit. I thought about something which just slipped my mind. Mongo. Yeah. The other thing to say about Meteor today is that Meteor has its own data layer, which is built on top of WebSockets, and it's called DDP. And it does authentication and data transfer. It's what enables this Meteor.call syntax. And MDG, the company that makes Meteor, a big part of their focus now is on Apollo, which is a GraphQL client and server. And so in many ways, DDP is it's likely that it will go away in favor of Apollo, or in favor of a GraphQL layer. And I think that, for me, this is one of the tragedies in some way of Meteor. They created a lot of really cool stuff. And when they launched, they were doing things like one of the things I didn't talk about actually, that Meteor does just out of the box, all data is automatically live. You have subscriptions just automatically. You push data to the client through the normal Meteor pipeline, and it automatically updates whenever the data changes in Mongo. And that's breathtaking in an engineering context. They've wired up this thing, they're watching Mongo's internal oplog, the Meteor has built this entire process to watch that, to figure out which oplog operations affect your current result set, to then push those updates to your clients automatically. This is all magic, right? It's super cool stuff. The challenge is it hasn't gone mainstream, and it doesn't really scale. Like, it has underlying challenges. It's a really, Meteor, this is kind of the story of Meteor. It's this awesome thing, but it just hasn't really, each individual part has started to lose out to some other kind of broader piece that's getting wider adoption in the JavaScript community. Anyway, so that's a bit about Meteor and sort of where it fits in the puzzle, and it's really about dynamic data, right? It helps you out with dynamic data. Which brings us on to Gatsby. So, Gatsby, what is Gatsby? So, fundamentally, Gatsby is a static site generator, right? It's built using React, I mentioned that earlier. And so, if you're building something like a blog, where the content is fairly static, or some kind of course that should be public, if you have a shop, for example, then you probably have a lot of static content. And one thing that is sort of one of Gatsby's defining characteristics is that it is insanely fast, right? Like, speed is at the heart of Gatsby. Gatsby is mind-bogglingly fast. So the traditional kind of dynamic flow, if you have a PHP-based application or Ruby on Rails or whatever, the classic model is the first thing that happens is the client sends a request to the server, right? Server gets that request, then goes to disk, gets some kind of code, loads that code, and executes it. Most likely, the next step is that the server goes to a database, tries to get some kind of data, what are the latest blog posts, or what is the blog post with this ID, whatever. The database then responds, passes some data back to the server. That data gets multiplied through the templates. There's a whole process, execution that happens, and an HTML page is built. The server then sends that page back to the client, right? And each of these steps takes time. And the more complicated they are, and the more database queries and so on that happen, the more time that they take. The end result is that it doesn't really matter how much you optimize it. This approach is always slow, right? There's just no getting away from it. It is slow. Now, this introduces a lot of caching, right? There's a lot of caching. You can do varnish full page caching, and you have Redis and other kinds of in-memory caches, and you have all these performance optimization techniques to take a slow paradigm and make it faster. And they work to a degree. Just with a small interlude at this point, there's a famous quote from Phil Carlton that says, there are only two hard things in computer science: naming things and caching validation. Right? So caching is definitely non-trivial. Anyway, so that's the traditional flow if you have a dynamic application. If you have a static application, the process starts out the same. Client sends request to server, server goes to disk. The difference is a static application, it doesn't get code from disk. It gets rendered markup from disk, and it sends that back to the client. And there's no work being done. All you do is go to disk, find the thing, and give it back to the client. And this is insanely fast. Like, normally, if you have something like a WordPress application, for example, your static files, like your images and your JavaScript and so on, will be insanely fast. Right? These will be really fast requests, while your HTML pages will be slow because they have all this work going on. So that's the sort of a beginner's kind of overview of like dynamic versus static sites. So the next thing is React. Because Gatsby is built on top of React, you use React to combine data and build it into HTML templates. I'm trying to remember what the next slide means. Right. So in a typical React application, where you have this, like something, for example, built with Meteor, this kind of single page application idea. In the React model, the first step is you fetch the HTML. So you get an index page. That index page will typically have a script tag in it. Like Meteor, for example, builds your whole application into two tags: script and style, combined style sheet, and a combined JavaScript file. You fetch the HTML, which gives you the URLs to the JavaScript. Then you fetch those JavaScript files. At this point, your browser will paint, right? So it will draw a blank screen normally, because that's the HTML that has been rendered. So it will paint a blank screen, and it will start executing your JavaScript. So it had to fetch it first, then now it's executing it. Most likely, that execution will in turn result in fetching data. You get some kind of data from the server. Now you're going to build a DOM, and finally you're going to paint again. Right? So in a traditional application that's built with React, this kind of single page application, you have this initial spinner that loads while the whole application is booted inside your browser. Right? And again, this is slow. And it's slow because there's a lot of work happening client side. In fairness, this approach is slow on your first page. Right? So your first interaction when you type in the domain is going to be slow. On the second page, after you interact with the page, it's going to be, the flow is slightly different. You already have all the JavaScript, and you probably already have the styles and so on, so you have the application running already. So typically when you click on something, it will then fetch more data, build a new DOM, and then paint. Right? So second clicks inside of a React application are typically faster than the first, right? But they're not, so they're faster than the first, but they're not super fast, right? There's still some work being done, there's still some network requests going over the wire. So that's a React application, which is like what you would get with Meteor if you use React with Meteor. or the typical kind of single page application. That's the architecture. Now to Gatsby. So Gatsby is a whole different beast. And what makes Gatsby fundamentally different is, like all static site generators, it has a build step, right? And so a lot of the work gets done during this build step. So the request flow is client goes to server, server goes to disk, gives that back to the client, and then pings. The key thing from a user interaction point of view with a Gatsby site, first paint, done. The user has the page. Like, the first paint has given the user everything that they need. The page is there. They can now view it. They can start scrolling. They can start reading. Their brain is now processing information that is on the screen. And they can interact immediately. While that's happening, while the user's brain is engaging, then Gatsby will fetch JavaScript files. Then it will fetch data. And it will fetch data even though there is no data required for the current page, right? So what it's really doing at this point is prefetching data. And Kyle mentioned in the contentful talk at Static Sites, any link that is visible in the viewport, so any link that the user has the ability to click on right now, the data and the components for that link will be prefetched. Which means that by the time the user has gotten around to click on something, the page load is nearly instant. It's instant from a human perception point of view, even on mobile. It's insanely fast. It's a disturbingly fast experience. It's so fast that sometimes in the beginning I would click something and think, what just happened? Did I lose consciousness for a second? Did I black out? Like, how is that possible? I learned recently that Safari actually prefetches the first result. So if you start typing something into Safari, and then you click on the first result in the drop-down in the address bar, it's already started to fetch that link. So if you wait a second and then hit it, it'll load instantly, right? So it's doing a similar thing. I never noticed this because I typically press the enter button faster than Safari can prefetch, so I don't really observe it. But yeah, Gatsby has this like instant second page click, which is insanely fast. Like, there's just no delay. And yeah, there's all kinds of videos on YouTube and stuff about people like, or discussions on Twitter about somebody saying like, but how did you make it so fast? Like, are you inside my house? Like, it's really disturbingly fast. Okay, so how does it?
Yes,
how does it work?
Can we interrupt?
Yeah.
I'm just thinking about how legal that is, because the poor people who are on a per megabyte plan on their mobiles, for instance, what happens when they enter a page with a lot of links and it starts to...
But it's usually just JSON, right? It's small packets of data. You're not touching the whole thing. Just
I guess it depends.
So you're like, yeah, there is this question about cost and so on. For sure, you're pulling data over the wire, and you're pulling that data when the user visits page number 1, right? In terms of legality, I don't think there's a legal issue in the sense that there's nothing on a page that says how much data will or will not be pulled. You know, there's nothing about a web page that says how much data will be pulled.
If people start to kind of question that fact that they go to one page and they are actually getting more or less the whole site immediately if they are careful. I remember before it was, now it's quite cheap to surf also if you go abroad, but
sure.
I used to be very careful when I...
So you definitely are loading more data, like that, there's no question about that. I would say two things. The first thing is that you can disable JavaScript. And one of the nice things about this is that the pages still work because they're fully rendered in HTML. So you can turn off JavaScript and you would deal with that. And I guess that I would assume that users that are at that level of sophistication that they're concerned about page size, they're probably turning off JavaScript. But that's purely a personal opinion. The second thing is that Google is pushing this concept called the progressive web app. And this is their core idea, that you prefetch links in advance of users clicking, and especially on mobile. So Google are actually advocating this on mobile. And they also do this in Google search results. So there are some search results that get this little instant kind of icon next to it. And if you click that, Google has pre-fetched a rendered version of the page so that you can tap it and instantly see the URL. You don't really get the whole URL, you get like a Google kind of served version of it as an overlay to the page that you can then X out of. So it's maybe a slightly controversial topic, but in the beginning I also thought like, whoa, this is a lot of data. It's something that seems to be a trend that people are pushing, and it creates a better user experience. So you can click on subsequent pages and they have this kind of instant thing. Yeah, I mean, I guess
I can see that. It's just that this, because we have on one side where you have a lot of Vodafone and everybody wants us to upgrade our plans for our internet, and on the other hand, kind of more hidden. We don't really know that we are actually loading more and more data that we never see, because that's the thing. We download data and
but then our
pay
browsers
for
don't
data
surface
that.
that. Like our browser doesn't surface how much data we're downloading. It maybe will do in developing markets and stuff. But this is a kind of controversial topic, but we can move on. It's not kind of core to the talk. So the question is, how does Gatsby do this, right? And the first thing to talk about in explaining how this works is how data works in Gatsby. So the first kind of starting point for data into Gatsby is what are called source plugins. So data comes from sources. That's the Gatsby terminology for where data comes from. And those sources can be quite broad, quite varied in their type. So one example, for example, is WordPress. You can use a WordPress site as a source for Gatsby. Likewise, Drupal, there are plugins for both, or Contentful, where we saw the talk from Kyle. You can use Contentful or other headless CMSs. So Contentful, you can think of it somewhat like the admin interface of WordPress minus the front end. So it doesn't give you a way to render the content, it just gives you a way to manage content. And then something like Gatsby takes that content and builds a site. You can also use markdown files on disk, for example, which is like Jekyll or Hugo. There are a bunch of other similar static site generators that use the same approach, where you have files on disk and those files in turn become a site. And so during the build process, and this is an important thing to conceptually understand, that at build time, Gatsby will fetch data. So this happens only at build time. Your source plugins will fetch data and push that data into Gatsby's internal system that it calls nodes. So it has its internal data structure where data is modeled into nodes. And that's the first thing that happens. All of your source plugins fetch all their data and push that data into nodes. The next thing is that to create pages. So Gatsby has this concept of a page. And a page is just a URL, so a path on the site, right? And you might, for example, dynamically at build time, you might fetch data in order to generate pages. So you can write any kind of JavaScript you want, it's asynchronous, so you can go away, you can pull all kinds of data, and you can then create pages from that. Likewise, you can use Gatsby's internal node system, and you can create pages from the nodes which Gatsby has created, its internal data model. You can use something like GraphQL to pull external GraphQL APIs. Now, this is less common because you can't get, the data that you get back from GraphQL is not available inside of your Gatsby node system, and the data is delivered to your Gatsby pages from nodes. So this is not that common a use case, but it's possible. More likely you would use this as a source to create nodes. And again, the same with request or fetch or any other generic thing. You can pull data from anywhere. And then this all comes down to a function called createPage. So you call createPage, which creates a page, and you give it a path. The path is just a like /blog, for example, or just /. And that tells Gatsby where the page should be delivered, and you tell it which component Gatsby should use to build the page, right? And Gatsby thinks in two terms. There is a layout component, and then there is a page component. So the layout component can set up things like your header and your footer and stuff like that, and then the page component gets dropped in the middle. I think the page component is actually called template, which is a bit confusing in the context of our whole component versus template thing. But anyway. So, Gatsby creates the pages, and then the way the data arrives into your pages, like data into pages, you can think of as nodes into components. So Gatsby's internal node system delivers data into components through GraphQL. Won't get into GraphQL because the talk is already running on in time. But yeah, GraphQL allows you to specify the type of data you want, exactly which field should be included, etc. And one of the key properties of GraphQL is that the query response is always JSON. It is serializable, right? Struggling to understand what the next slide is supposed to be. Yes. So, you build JSON. Now, in order to build HTML, you specify a component, right? I don't know what those two slides meant. You skip that. So, React. You have a component, it's a React component that is specific to each page or for a layout. That component has a query, right? Has a GraphQL query, and that specifies the data that's required for that page. So at build time still, Gatsby will fetch the JSON that is required to put the data into that page, and then it will write that JSON to disk. And so your data that went into your Gatsby node system is now compiled out into static files, right? And so you can take dynamic data sources, and what you end up building is this gigantic mass of static files that contain all of your data. And then you can use React. React has a render function where you can render to HTML, and again you can write the HTML to disk. And that's the fundamental of how Gatsby works, is it writes out one full HTML page for every single path, and then it writes out the data for that path, and then it writes out the components that are required, and then it can fetch all of those things independently. So it doesn't have to fetch the full HTML of every single page, it just has to fetch the data for that page and the component. And if it already has the component, that's not necessary. Now, we'll take a little detour at this point into the contents of the HTML. So the first thing is, the HTML includes all of the CSS that is required, right? And that CSS is inline. So, and because of the way that React works, I mentioned this earlier, like the styles are put inside the components, it only contains the CSS that is required for the page. It's not a single CSS file that's built for your entire website. If a CSS directive is only used in another component, it will not be included in the built HTML. The HTML even includes images. So it includes like these small kind of base64 encoded like placeholder versions of your images, right? Which is, again, they're all built during the build process. The key thing here is that everything required for that first paint is delivered in one single request. There is no request for CSS. There is no request for an image required. There's no request for JavaScript. One request, one document, one file, and the browser has everything it needs to paint the page. And this is ridiculously fast. It's not only fast, it's insanely fast. Like, you can routinely expect to see Gatsby sites scoring 99 out of 100 on speed tests. Like, it's insane how fast they are. Because every trick and technique that you can use to build super, super fast websites is built into Gatsby. That's the kind of vision, right? The vision is that all of the stuff that you would be doing if you had the time and the energy to go and become a performance master is just done for you out of the box. Webpack is configured and tweaked and optimized. Images, the whole process, everything is all part of that process. So you get these ridiculously fast pages. So Gatsby is fast not only because it's prefetching, like we talked about, but it's fast because that first page is optimized as much as is reasonably possible. You'll need to do a little bit of tweaking to get it up to 99. Like if you just create a Gatsby site out of the box, you won't get a 99 score, you'll get probably an 80 something. But you can get it to 99 with a few plugins and tweaks. insanely fast. So the output from this Gatsby build process is HTML, JSON, JavaScript, and all of it is built static files, and it's all placed on disk. And then there's a whole section of this talk missing. No, there's a whole section more coming. Yeah. Any questions at this point? Next, I'm going to talk a little bit about when you would use this and when you wouldn't use this.
Yeah, maybe a couple of questions. So basically, depending on our URL and page structure, every possible variant of our page is pre-built.
Correct.
During the build step.
So every variant of a page is built during build, yeah.
Yeah, exactly, yeah. So basically this HTML document, does it already contain the data that's also in the JSON inside the actual HTML? So basically...
So how much of the data is embedded in the HTML?
Yeah, exactly that.
So the HTML is fully rendered.
Okay.
There's no like dynamic, there's no React.
So it's all inside. So basically it would be safe to say that for every page there's also a matching JSON somewhere there outputted. Possibly.
Every page gets HTML and JSON,
yeah.
but the
Basically two
HTML,
files.
but the HTML
Already includes the data from the JSON.
No, it doesn't really include the data. What it includes is the rendered markdown. So in that example of the UL tag where you had like 5 UL tags, the 5 LI tags with the individual name are rendered in HTML. Okay. There's no code happening.
Yeah.
So the browser just reads the HTML, processes it, builds the DOM, done. There's no like, it doesn't have to load JavaScript.
Mm-hmm.
Yeah.
And the JSONs are then used, for example, if we load the first page, okay, it's all in the HTML, it's loaded super fast, and for example, I scroll down to a link, the link
JSON is used to prefetch,
reaches the viewport, and then the JSON is fetched.
JSON is used to prefetch, not for the first page.
Not for the first, but every subsequent.
Yes.
For example, in those use cases.
Yeah. So any page except the first one that you visit,
awesome.
You won't download the full HTML.
Okay.
You'll just download the components and the data as 2 separate files. The data is actually written as JavaScript files as opposed to JSON files.
Okay.
It's a
but we
small
can
detail.
conceptually imagine them as
Exactly.
Okay. Then just maybe one more thing. So this, like in a classic React application, you always load like an HTML file that usually has just like a single div, something called ID as app or something like that. Then we load the JavaScript, which contains React and all of the React libraries and so on, which then inserts the whole React system into this one div. Here we're already loading all of this HTML, and what you're saying is that after the HTML is rendered and painted, this whole JavaScript bundle will be fetched and then loaded, parsed, and so on. And well, my question here, I guess, is how do these, up to a certain point, these are just plain HTML elements. Like,
so how does the HTML...
At which point do they become React elements, and how does this transition happen?
So how does
you know what I mean? Like,
what's the relationship between the sort of pre-rendered HTML and the
Exactly.
HTML, the virtual DOM?
Exactly, yeah.
So React supports server-side rendering, which means that in addition to just having all of your React, like just having your HTML, there will be additional attributes on the HTML tags which have this React ID X, and that allows React to diff its virtual DOM against the live DOM and not have to make any changes.
Because there won't be no changes. Because the initial state will be the same, right?
Because the data is dynamic. Yeah, but React, I think, I'm pretty sure React doesn't even necessarily need to fetch your data for the current page. I'm not 100% sure on that.
Anyway, this happens seamlessly, basically.
Yeah, there's no flash, there's no paint, there's no reload, there's no white flash where it like paints the first thing and then repaints the same thing on top. It just React just smoothly takes over the DOM.
Exactly, yeah. That was my question. When does the like regular HTML become like a React virtual DOM? Is this what, like I read about this sometimes, is this what they refer to as like this rehydration or hydration? Is this
no
a term?
Rehydration is, well, maybe. Rehydration for me speaks more to Redux state. So you can rehydrate your Redux state, which in turn will potentially mean that you end up with the same rendered virtual DOM, which in turn would mean that you can take over.
Okay, but that's a detailed question. Okay, thanks.
Good. So why would you do this? I've mentioned it before, but I'd say it again, like it's the main reason it's fast, right? Like it's super, super fast. Gatsby is absurdly fast. Amazon did some research. I spent 4 or 5 years doing web performance, so this is one of my passions. Amazon did some research. They found that for every 100 milliseconds, so 1/10 of a second, if they slow down the loading of a page by 100 milliseconds, they lose 1% in sales. So speed is everything. Speed is super, super important. And that's, Google also did this thing where they changed the default number of results from 10 to 30, but the click-through rates went down because the page took longer to load. So they ended up going back. Even though people want more results, they're not willing to wait for them, so the actual click-throughs are lower. And that's why, like, speed is really the number one thing online. Like, it's not the number one thing, that's not fair, but speed is hugely important. If you can improve your speed, make your site load faster, you will get better retention, better click-through, better engagement, etc. So speed is huge, and speed is money. And anything, if you have anything where you're making money from a site, speed is money. Another big aspect is security. So static sites, like Gatsby sites will be, they're super secure in some sense because it's just static files, right? All you did is build HTML, JavaScript, CSS. There's no server, right? So there's nothing going on. There's nothing to hack. You know, you can't. I mean, that's not totally true. You can try to hack Nginx, for example. Like you can just put a site, a Gatsby built site behind Nginx, or you can put it on a CDN, for example. You can put it on Amazon S3 with CloudFront in front of it. You can try to hack that. But it's like a totally different paradigm than trying to exploit weaknesses in your WordPress site, for example, with X number of plugins, which I can discern from the code that's generated. Often they write a helpful little output like built by X plugin version, blah, blah, blah. So like all of that security stuff just goes away. You don't have code running on your server. So there is no server. The security paradigm is radically simpler. It's also cheap. Like it's much cheaper to host static sites. It takes far less CPU cycles, et cetera, than having a server that does all this build stuff. This is not strictly true if your site has very, very low traffic, and you make frequent changes, then perhaps you will spend more CPU time doing building than you would do serving requests. But in general, you're creating something that is incredibly simple, and therefore it's cheap to host. You can put it on standard FTP web space, for example. You don't even need PHP. Like, it's hard to get the hosting requirements to be lower than for a static site. And another big aspect of simplicity, this is something that I think about a lot in terms of like hobby projects, hackathon stuff, longevity. Like, I often have started projects where I've put something on WordPress.com because 2 years down the line, if I no longer want to pay the domain fees, the site lives on, right? The content will live on. And so if you have like I had old applications that I built in PHP or old Node stuff, and it's just difficult to maintain, it's difficult to host, there are upgrades required. I moved to a new server, I can't run the old version of PHP that I was running anymore. It's not supported, it's not security updated. My code is now not compliant with my PHP version, I have to make changes. There's this concept of software erosion, and static is about as simple as it gets. So you build a static site, that site can live on forever. Like modern JavaScript browsers still understand how to parse old JavaScript. So even if your JavaScript gets out of date, the static pages in HTML are likely to still work a long time into the future. So what sort of things would Gatsby be a good fit for? I mentioned earlier, like if you're doing a blog, for example, this is a good fit. Anything e-commerce, if you're doing anything where people are supposed to buy something, then speed is huge. And in that case, Gatsby would be a big help. Also, because often for e-commerce, all of your pages are can be rendered in advance. Like I spent years doing web performance in e-commerce, and this was the vision that we had, was to get all of our pages rendered in advance. So we had a complicated caching system with a PHP Magento application, a full page cache in front of it, scripts to artificially warm that cache so the pages were always served from cache to real users, etc., etc. But we weren't doing any prefetching, and our pages were not that optimized. So if you're doing e-commerce today, Gatsby or something like it is going to be of a huge help. And anything that looks like a website, like if you have a website where you want people to browse content about your product, about your business, whatever, and like look at pages, then again, speed is going to be huge, and the simplicity here is going to be a big win. When would you not want to use Gatsby. So Gatsby is great for certain things, it's not great for other things, and it has some limitations. The most obvious thing is if you have highly dynamic content. So if you have anything where each user should see a specific view dependent on their login state, that's just not going to be a great fit for Gatsby. So if you're building a chat system, for example, every user is seeing something different. If it's highly social, some kind of social application or whatever, this is not a great fit for Gatsby. Gatsby can do client-side routes, so you can have dynamic data which does not get pre-rendered. That's totally possible, and so often you'll see, for example, people will split their site and their application onto two different domains. This is a common pattern. If you use Netlify, it's app.netlify when you log in, but it's netlify.com when you look at their pricing information and so on. With Gatsby, you could, in theory, put those two on the same domain, and you could have them at the same path, or you could have them in the same site. It's totally possible. It's a per use case basis whether it really makes sense. Like Gatsby is great where you have content that changes not all that frequently. Yeah. Another thing is Gatsby doesn't really work very well if you have more than 1,000 pages. So if you're looking at really big sites, some of the things we're working on trying to make this better for Gatsby v2, but right now, included as part of the HTML built for every single page is a list of all the other pages, which is a bit of a kicker. Once you get up to 1,000 pages, for example, this can be hundreds of kilobytes of data, and that data is included in the build of the HTML build of every single page. It doesn't strictly need to be, but right now that's the way it's set up. And so, like, I'm working actively on some Gatsby tickets around this, trying to look at ways to improve this, but it'll probably only land in v2. And yeah, so if you have, right now today, if you have sites with huge numbers of pages, Gatsby's not going to be a great fit. And what matters here is the number of pages, not, for example, the number of blog posts. So I was looking at my personal blog and about moving it over to Gatsby, but I have 3,500 pages. Not because I have 3,500 blog posts, I only have about 2,000 blog posts. But then I have pages per category and pages per tag. And so when you combine all that together, I end up with 3,500 pages. And Gatsby in development, for example, will not run on Chrome. There's like a range out of memory error because the heap is not large enough or something. So very large numbers of pages, not going to work well. Likewise, if you have only one page, like if you just have one of these classic one-page kind of scroll down the page sites, then Gatsby's going to be overkill. Maybe it makes sense in the sense that you'll get this highly optimized single page, so you could think of it as useful in that sense. But in general, if you have a single HTML page site, then Gatsby is probably not the best tool for the job. Boom. Any questions? I thought this presentation would be significantly shorter. I was concerned that it would be too short, in fact. Great, well we can turn the video off, and then if you have questions we can dive into them. Thanks for coming.